ठीक, अब ध्यान से देखें. So we did till over here, isn't it? We completed till over here, and we got the idea what is electric field and all. Today, I'm going to take a offbeat or off track. We started doing the electric field of rod and all these kind of things. Okay, but one thing is there in my mind that when we are learning electric field, like during the start of this electric field class, I told you that in electric field we have two things, isn't it? So look over here. Where is that slide? Yeah. So try to understand. See, when we started this electric field topic, we told that there are two ways to understand the electric field. One by electric field intensity or strength, and another thing is by electrostatic potential. Word or not? And these two both plays a very good role in understanding this whole thing. So we understood electric field. We even did the questions of electric field lines, then questions related to electric field. Then we got to know about charge distribution, and we did the electric field calculation for one of the case, which is rod, isn't it? But I want to do the things simultaneously. Like I want to write for each and every case of charge distribution the electric field and electrostatic potential at the same instant of time. So that is why today I want to make you understand electrostatic potential. Word or not? So from this our whole lecture will start. Okay. Now try to understand. We know that let's suppose if I have a positive charge, if I have a negative charge and a positive charge, okay. So this is plus Q and this is minus Q. Word or not? Now, if the electric field is towards this side and on this the electric field is towards this side, means for both of them the electric field, okay, let me plot like this way in the same fashion. So the electric field for both of them is in the same direction, isn't it? Then we told that they experiences some kind of a force. So plus Q will experience the force in the same direction of the electric field and minus Q will experience the force in the opposite direction, isn't it? And these forces, and then we told that this force is exactly equal to QE vector, isn't it? Now, this is another kind of force. This is a total different kind of force which you got to know, isn't it? So, what is the difference basically? So, in class 11th, we know that Newton prescribed us a force, isn't it? And Newton gave the rule that yes, we have a force, and if a force is present, then there is interaction potential energy is also present, isn't it? है कि नहीं? Interaction potential energy means if a object is nearer to another object, then it feels that some kind of potential energy is stored in that body, isn't it? है कि नहीं? Potential energy तुमने पढ़ा होगा, ठीक है कि नहीं? पढ़ा है ना? ये बताओ. You have heard about that gravitational potential energy or not? So when another body is nearer to another body, then we have gravitational potential energy. Then we have many kinds of spring potential energy. So whenever there is an interaction of forces, then we got to see that there are some potential energies which are present over there, isn't it? In similar fashion, in a this electrostatic field, there is a scientist which we know by a name as Faraday. There is a scientist whom we call it as Faraday, got it or not? And that scientist provides us, means he actually gave us the idea. 1 minute. Let me just open this. Is spare non-conducting portion of charge field lines. 1 minute, just 1 minute. I want to open ठीक. So Faraday was there who actually gave us the idea that for our similar kind of force, there is an force which exists in electrostatic field and that is created by electric field. Are you able to get me or not? And then you know that anything which experiences force will have some interaction potential energy or not. So he called that potential energy to be electrostatic potential energy. Right? Is that clear? So there is force, then there is its potential energy. There is force in the electric field which we give it as QE, and then there is I have a potential energy of that. Are you able to get me or not? Is that clear? So before discussing potential, I'll discuss about potential energy first, and then I'll discuss about potential. Are you able to get me? Is that clear? So look over here. How do we talk about potential energy? Simple. Potential energy is created when there is work, isn't it? So now look over here. Let's suppose. अच्छा, अब मैं पोटेंशियल एनर्जी का मतलब समझाता हूँ. पहले समझो. जैसे पहले हम फिजिक्स वाले मतलब 11th क्लास वाले पोटेंशियल एनर्जी का मतलब समझेंगे. देन आई विल मूव अहेड. ठीक. जैसे मान लो यू नो अबाउट जैक एंड जिल went up the hill and Jack fell down and went broke his crown, isn't it? हाँ, जो भी है. तो एक बात बताओ. Look over there. Here is my Jack. Okay, let's suppose this is my block of mass m, isn't it? Now, you brought this block up away to this top of hill. Where you brought this block? At the top of the hill. It was here, and it has been taken over here. Okay. So you only tell me, when I take it to top of hill, some work has been done or not? Some work has been done. Work has been done, isn't it? Now you only see that when the body which is kept over here, if I just release it, when it will once again come down, at the downward point it will have some velocity or not? It will have some velocity. That means although see, when it is coming down, no one is trying to do the work, isn't it? We say that the gravity is doing work, but keep it in that in mind, that no one is trying to do the work. It is coming automatically downwards. Are you able to get me or not? So when it is coming downwards, it gets its velocity or not? The question is that how does it gets its velocity? See, I brought it from the rest and then I kept it over here. But when it is coming down, it gets its velocity, isn't it? So that means to provide that velocity, some of the energy should have been already present over there, isn't it? And that is my what we call it as energy which is stored due to the work. Due to work. Are you able to get me or not? If I say that what is the potential energy of a ball which is kept on the ground, not at height, you will say that its potential energy is zero. Because we didn't perform any kind of work to take it to some height which can be stored as energy. Are you able to get me or not? Okay. So you got the idea of potential energy. What is the potential energy? It is the energy which will be stored in the body when the body when on the body after performing work, the body comes in rest. Are you able to get me or not? Just like a spring, take an example of a spring. When it is normal, it has no potential energy. But when I stretch it, I did a work, but then the body is at rest or not. But after this, when I release it, the body gets velocity. How does it get its velocity? That is only possible if there is some energy initially, isn't it? So that work which you did to stretch it is got stored as spring potential energy over here. So what is potential energy? The the energy which is stored after performing the work is called as potential energy. Is that clear or not? Did you got the idea what is called as potential energy? We didn't did that much depth discussion in work energy power, but right now we have to discuss it. Are you able to get me? So let's suppose if I have two charges, Q1 and Q2, which are separated by some distance R. Okay, I have two charges which are separated by some distance R. Now, look over here. So you only think. Okay, one thing is there. Let us just do one thing. Not keep it at. Okay. Let's suppose this charge Q2 was present over here, somewhere far, somewhere where far, wide or not, which is located at. I call this as distance R initial. What I am calling it as R initial. Are you able to get me or not? And then this Q2 is brought over here nearer to R final. Are you able to get me? So this is my initial position of Q2 and this is my final position. And this charge is fixed. Are you able to get me or not? Now you know that when I'm bringing this charge towards this side, I need, see, this particular charge Q2 is experiencing a Coulomb force over here or not? And that Coulomb force is F is equal to K Q1 Q2 by, means you look over here. One thing is very interesting about over here, that as I am varying, see here the Coulomb force is different, here the Coulomb force is different, here the Coulomb force is different or not, and I am bringing it much more closer to Q1. So more Coulomb force it will experience or not, and more work will be done as I am bringing it nearer and nearer. So therefore I write the Coulomb force for some random distance x. When the charge Q2 was at x, okay, when charge Q2 was at some random distance x, for that I'm writing my Coulomb force. Are you able to get me? Yeah. Is that clear? Okay. Let me erase this. So the Coulomb force experienced by Q2 is towards this side, while the displacement is towards left side, isn't it? Are you able to get me? dx is towards left side. So you know that Coulomb force will be given as what? K Q1 Q2 by how much how much square? X square. And we know that earlier that electric field, we called electric field force as a kind of conservative force. Which kind of a force? Isn't it? The reason for that is very, very simple. That initial value and final value depends on potential energy. That's why we call it as conservative force. Are you able to get me or not? So when it is called as conservative force, we know that the work done by this conservative force will be integral, or sorry, minus integral, sorry, minus of change in potential energy or not. But that is equal to what? Integral F dot dr. Yes. So when I am moving the body by a very small amount towards right side and the Coulomb force is experiencing on the left side, so work done will be what? Simple, it will be minus of Coulomb force dot dx, isn't it? So what is my Coulomb force? K Q1 Q2 by x square into dx, and that too in negative sign. Are you able to get me or not? But from where this x is brought? X is brought from this initial point to this final point or not? So which is R initial to R. Yes. So when you solve it, what you are going to get? It is exactly equal to minus x square integration. It will be k q1 q2. X square integration will be minus 1 by x, isn't it? Because it is x to the power of minus 2, so minus 2 plus 1 divided by minus 2 plus 1, so it is minus 1 by x, and that is r initial to r final, means r, isn't it? So what I got as equation? K q1 q2 1 by r initial, sorry, 1 by r minus 1 by r initial. That's my work done. That's my work done, isn't it? Minus minus, it will become plus or not. Got it? Is that clear? So now look over here. Can I just move ahead directly? So you can see that clearly. I got the idea that our simple work done is k q1 q2 by 1 by r minus 1 by r initial when I bring the 2 point charges nearer to each other. ठीक है? That's my conclusion. But the point arises that when I'm bringing it, I can bring it from anywhere, isn't it? Are you able to get me or not? So let us just do that. Okay. So I got my work done by the Coulomb force as K. So this is my work done by which force? Coulomb force. Okay. Which is equal to minus, sorry, it will be K1 Q2 by 4 pi epsilon naught into 1 by R minus 1 by R initial, isn't it? That's your term, whole term. कुछ तो बोलो हाँ या ना. अच्छा, अब ध्यान से देखो बेटा, तो जो पर्सन, सी, the person who is trying to move this charge towards left hand side should apply exactly the same amount of force to move it towards left side or not. So at that time when you are considering, when we consider, see, when this is the work done by the Coulomb force, right or not, but actually the work is done opposite of the Coulomb force or not. So work done by external force is actually negative of work done by Coulomb force, and that's what we are relating. What is the work done to bring the charge q2, q2 from r initial to r final r, isn't it? So basically that will be the work done by the external, isn't it? So work done, so directly I'm writing work done external as just work done. That will be how much? Minus of q1 q2 by 4 pi epsilon naught 1 by r minus 1 by r initial. अरे कुछ तो बोलो हाँ या ना? That is the actual work done by the person. Are you able to get me? So now that this work done, this only work done will be stored as potential energy. So we'll relate it now. We know that the work done is related to potential energy as minus of change in potential energy, which is U final minus U initial, and that is equal to minus of Q1 Q2 by 4 pi epsilon naught 1 by R minus 1 by R initial. So minus minus cancels, and we have the final relation of u final minus u initial always is exactly equal to q1 q2 by 4 pi epsilon naught 1 by r minus 1 by r initial. Are you able to get me or not? So look over here. That's what is our conclusion, that if I have two charges, okay, two same charges, sorry, one is fixed and one is movable, okay, and this is plus q1, this is plus q2, and I bring this plus q2 from some r initial, okay, to nearer to r, void or not? Okay, so then it's actually some work is done by the external quantity, and that external quantity increases the potential energy of this interaction. Are you able to get me? So work done over there. So therefore the change in potential energy. Here the potential energy was U initial. Here my potential energy is U final. Are you able to get me? So U final minus U initial is given as Q1 Q2 by 4 pi 1 by R minus 1 by R initial. Now let's suppose of one case. What if charge Q2 was brought from infinity to 1 by r, I will change to what? 0. And then I at infinity, what is my potential energy? 0 only. It will become 0 only or not? At infinity, is there will be any interaction at infinity? Remember that there is no interaction at infinity, isn't it? When you can't have interaction, then you will have 0 potential energy or not. So what is my, yeah, so you will get U final. If you bring the charge from infinity by doing some work, then the U final is just Q1 Q2 by 4 pi epsilon naught into R, where R is the final distance between the charges. Are you able to get me or not? Now you got the idea? Hmm. 1 minute. Let me check if I have any. Okay. Close. You got the idea or not? So let us move on to next point. So this is what we got as our potential energy. Are you able to get me or not? And this is what we define. We define now. This is this is called as electrostatic potential energy. Are you able to get me or not? And as this is coming from work, potential energy, you know that it is a always a scalar quantity. Is that clear or not? मेरी बातें समझ में आई? Now you have to always remember that the potential energy is sign dependent. Got it? Means like in vector case, when we take the direction, we ignore the sign of the charge or not. That means here, do not ignore, इसमें लिख लेना, do not ignore the sign of charges. ठीक, अगर मान लो नेगेटिव चार्ज, if a negative charge would have been brought here, the potential energy should have been negative. Is that clear or not? Okay. Okay. Now, so we got to define. See, I had the force, I had the interaction, so I was able to define my interaction potential energy, which we also call it as electrostatic potential energy, which is given as Q1 Q2 by 4 pi epsilon naught R if the charge is brought from infinity. Are you able to get me or not? Now, you look over there. अच्छा अब एक बात बताओ. If this charge Q2 will become heavy, it will be very hard to move. Yes. Not by mass. Means if the charge Q2 is bigger, then it will be hard to move nearer to Q1 or not. Magnitude of the charge, isn't it? Because it will experience much more extra force, isn't it? So this change in potential energy, 1 minute, sorry. This change in potential energy depends on moving charge. Depends on moving charge or not. Look over there. As I am changing my potential, ठीक है. So then at that time, the particular potential, as I'm trying to change my potential energy, it depends on the charge which is moving, isn't it? So देखो इसका मतलब क्या चल रहा है कि अगर let's suppose if I have any charge which is kept over here and I am bringing another charge, okay, from somewhere over here, right or not? So first thing is that this charge, if it is a positive charge, both are positive, plus q and plus q. So this charge is also experiencing some kind of force, isn't it? It is experiencing some kind of force. Are you able to get me or not? With the force, it is also experiencing some kind of electric field. Yeah. And then suddenly it gets its potential interaction potential energy. If it is at R, its potential energy is defined as K Q1 Q2 by R. अरे कुछ तो बोलो हाँ या ना. इसका मतलब क्या है कि अगर तुम खुद सोचो, अगर ये चार्ज यहाँ से यहाँ तक आया, तो once again its potential energy will change or not? It will change. That means that apart from the electric field, apart from the force, there is something which is more, which is acting on the charge, and we define for the charge just like electric field. Just I have the field of the charge now. So similarly, I define a scalar quantity of the charge, which we call it as potential of the charge. Means ability to affect the another external charges. Are you able to get me or not? See, you only see when I bring this plus q2 over here, it has less potential energy. When it is coming over here, it has more potential energy. When it is coming over here, it has more potential energy. When it is coming over, it has maximum potential energy or no. So as it is coming nearer, its potential energy is increasing. Increasing or not. Apart from that, this charge quantity is constant. Yes. So that means something, some kind of field, means the intensity of field is increasing over here towards left side direction. Yes, isn't it? But the force and field are working in which direction? Towards the right direction. So how come the potential energy is increasing? It is increasing only due to presence of some another quantity which is measured as intensity, and which is increasing as I am moving closer to the charge or not. So basically, there are two ways to measure the intensity of charge, and one is called as electric field. Another thing is called as electric potential, not potential energy. What it is called as? Are you able to get me or not? So the difference between them is very common. Electric field is a vector quantity which handles all the vector equation, and electrostatic potential is a A scalar quantity which helps us to understand the scalar nature of the charge. Are you able to get me or not? No, electric potential is totally different from potential energy. We will get to know. Are you able to get me? So look over here. Let us see. Let us define this. So let us define how the electrostatic potential or electric potential is different from potential energy. Got it? Let us see that. Okay. So it is defined as work done per unit charge per unit चार्ज चाहे ऐसे लिख लो, थोड़ा सा अच्छा डेफिनेशन नहीं लग रहा है, ऐसे लिखते हैं वर्क डन बाय द एक्सटर्नल एजेंसी ओके टू ब्रिंग unit test charge from infinity to the field of another charge very slowly. ठीक, देखो दो चीज मैंने बताया. अब क्या कर रहे हैं, देखो जैसे ही तुम चार्ज को लेकर आ रहे हो, तो चार्ज करने में वर्क डन हुआ है या नहीं हुआ? सम वर्क इज डन, यस. So electrostatic potential is defined as, which is electrostatic potential का डिनोशन होता है कैपिटल बी. क्या चीज डिनोट करता है? या ओके. Then it is not the total work done. It is exactly equal to how much is the work done required by the external agency to move our moving charge. Are you able to get me or not? It means it means that work done, how much you are doing the work done to move a charge, that should be actually related. Okay, means there was no quantity which actually used to relate this charge, that if this charge becomes bigger, what, how come I'll do the work done extra or something like that. So that was actually denoted by what? Our electrostatic potential. Are you able to get me or not? Net work done, yes, it is a net work done. Is that clear? But you know that the work done in electric field is simple, but change in potential, isn't it? But our U initial is going to be 0 because the charge is brought from infinity. So it is just interaction potential energy finally, U interaction divided by charge which is moving. Now you got the idea that what is the difference between the potential energy and potential. That potential energy is the work which is stored, while the potential is talking about how much you had the capability to move that charge. Are you able to get me or not? That is called as potential. Are you able to get me? Yeah, so it is talking about two things in the same way. देखो जैसे ही हमने potential define किया, that it is defined as potential energy per unit charge. So basically it is talking about this fixed charge or not in a correct fashion. See, basically if this fixed charge is very strong, then this charge which is positive will feel much more like you will have to apply much more force to move towards this side or not, and in such a way the potential energy will increase. Are you able to get me or not? But if the fixed charge is very very small, then this plus q will not have to apply that much of the force to move towards this side. Are you able to get me on? So electrostatic potential, in reality, it's not talking about this moving charge, but actually it is talking about the fixed charge. But the formula is given through the moving charge. Are you able to get me or not? देखो मतलब पॉइंट समझो. अच्छा, ये अपने पास फिक्स चार्ज है Q1, हम Q2 को लेकर आ रहे हैं, है ना? तो Q2 के ऊपर अपन ने वर्क किया. Q2 के ऊपर some kind of external work is done such that it should move. Okay. Now you are feeling, you as an external agency, you are feeling that I'm moving Q2 in front of Q1. But actually, if I just remove Q1, then there is no use of external force or not. So who is actually creating the force? Q2 के ऊपर कौन force लगा रहा है? क्यों? एक force लगा रहा है कि नहीं? Now, if that force is present, if that much big force is present over there, so look over here. If I do my work done, right or not? So for external agency, it will feel like no that I am doing some work, and if this Q2 is bigger, I will do less work. Are you able to get me or not? Isn't it? Sorry, I'll do more work. So that is why he told that for me, the electrostatic potential means what is my capability at all these different points. That depends upon work done. First, if work done is more, capability of external body, right or not? So that means my work done will be more if Q2 will be less effective. Are you able to get me or not? If Q2 will be more effective. Okay. अच्छा देखो एक एक मिनट मैं बता रहा हूँ. समझो. अपने पास Q2 है और Q1 है. चेंज कर लो नेम्स 1 मिनट. Q1 एंड Q2. ये कैसा है? फिक्स्ड. और ये कैसा है? मूविंग. अच्छा Q2 कहाँ जा रहा है? लेफ्ट साइड. तो एक्सटर्नल एजेंसी को वर्क डन करना होगा. तो एक्सटर्नल एजेंसी सोचो जरा. एक्सटर्नल एजेंसी की वर्क हर पॉइंट पे चेंज हो रही है ना. यहाँ पर कम है, यहाँ पर ज्यादा है, यहाँ पर ज्यादा है, यहाँ पर और ज्यादा है ना. तो एक्सटर्नल एजेंसी क्या सोचेगा कि मेरा कैपेबिलिटी हर पॉइंट पे वैरी कर रहा है नहीं कर रहा. तो उस वो अपने एबिलिटी को पोटेंशियल से डिनोट कर रहा है, मेजर करने की कोशिश कर रहा है. क्या चीज से? पोटेंशियल से. So potential will be directly proportional to my work done or not. More work means more potential. If I do the work like this way, then I have more potential or not. So this potential is of which one? External agency. When I talk about Q2, okay? Are you able to get me? But if the Q2 will become bigger, the potential will decrease or not. So work done by Q2. So this potential, yeah. So this potential relates what? This potential, according to this formula, is of. So potential of external agency we are talking about, isn't it? Are you able to get me or not? Now, what is that thing? Potential, this work done and this Q2. Leave the thing about Q2. Think of the work done. If Q1 becomes stronger and stronger and stronger, the work done will be more and more or not. So this potential also, which is actually related for external agency, is also related for Q1, isn't it? अभी बात समझ में आई? So potential is like the ability to do work. Are you able to get me? Yes. So now if Q1 is fixed, अगर Q1 fixed है and this is the potential which can also talk for Q1, that means that if Q1 is fixed, it is means fix होने के बाद भी वो Q2 को affect कर पा रहा है ना. Q2 यहाँ पर है तो बहुत ज्यादा वर्क करना पड़ रहा है Q2 को. यहाँ पर है तो कम वर्क करना पड़ रहा है। इसका मतलब क्या है कि द पोटेंशियल ऑफ Q1 मीन्स एबिलिटी टू अफेक्ट Q2 is decreasing as the Q1 is moving farther and farther or not. So basically the potential of Q1 and potential of Q2 are interrelated with each other. कैसे है? Interrelated. Are you able to get me? So when I talk for the work done and moving, I'm talking about the potential of an external agency. Yes, that when I go nearer and nearer, my work done is increasing. So definitely there is something which is preventing us, right or not? So potential will be directly proportional to work done. But divided by Q2, why? Because if Q2 increases, then suddenly I'll have to do extra work. Are you able to get me or not? Means more ability I'll have to apply. Are you able to get me? So that's what is called as work done for the Q2. But if I talk about as I can see that here work done is more, here work done is less, here work done is less for Q1 respective, isn't it? So that is only possible if some ability of Q1 to affect Q2 is decreasing, isn't it? And that if the interaction is interrelated, so this potential should be also interrelated. Are you able to get me? So this potential represents the potential of Q1 also and potential of external agency. Is that clear? Now you got it. Now work done is potential energy final divided by Q2. What is potential energy final? 1 by 4 pi epsilon naught Q1 Q2 by R divided into Q2. So Q2 got cancelled and 1 by 4 pi epsilon naught Q1 by R is my potential equation for the rest charge. That's why I told you that these two potentials are interrelated. Are you able to get me or not? Now you got the idea. So, so 1 minute. I'll just write that this potential is also an scalar quantity, and it is exactly equal to. It has a unit which is exactly equal to volts. Okay. See that. Okay. 1 minute. Uh, 1 minute. ठीक है, तो ये पॉइंट समझ में आया मेरा क्या? आर एबल टू गेट मी? So basically they are in, remember that potential energy was the interaction, right or not? Potential energy was talking about two charges at the same time when they are brought together, while electrostatic potential is talking about own self, that what I am doing. Are you able to get me? ठीक, तो जैसे मान लो एक एग्जांपल है, दो भैंस को बांध दिया ऐसे, there are two cows which are attached together. So when I talk about whole system, then I will talk about potential energy. When I will talk about which one is pulling farther and which one is affecting what, then I will talk about their ability. Then I will talk about their ability to affect each other. Are you able to get me? हाँ, so उस ability का नाम है क्या? Potential. Are you able to get me? Okay. And ability to do work is called as energy. Okay. Just the ability is called as potential. Okay. So look over here. Let's suppose that's why we define the potential due to a point charge. ठीक है? So let's suppose if I have any point charge, Okay, plus q kept over here, and I want to find what is its potential, means what is its ability to affect another charge over here at this distance r. समझ में आया बात? What is potential? Just like field was there, na, field was applying the force. So potential talks about how much it can affect the other particle. Okay. So then potential of this charge, fixed charge at point P, is given as 1 by 4 pi epsilon naught q by r. Are you able to get me or not? And now, if another charge appears over here as capital Q, then this capital Q, we know that it will experience some force, isn't it? So, for this capital Q, if I talk about how much potential this capital Q should have or external agency should have to move it, then that particular potential of our external agency or capital Q should be exactly equal to the amount of work done, yeah, by moving charge. Are you able to get me or not? Is that clear? Okay. Now give the heading. Potential due to system of charges. So let's suppose if I have many charges, got it? So now let's suppose if I have charges like this way, okay, one is plus q1, another one is minus q2, another one is plus q3, and you want to find the potential due to all of them at this point, right or not? And they are brought from infinity, and they are already assembled. Remember that they are already assembled, right or not? And you want to find the potential at point P, which is located at R1, R2, and R3. As these all charges are our scalar quantity, so potential at P will be simple: potential due to 1 plus potential due to 2 plus potential due to 3, isn't it? Because it is a scalar quantity. Superposition, but without the vector sign. Why? Because all these are a scalar quantity and they can be added or subtracted normally. Are you able to get me? So potential due to at point P will be what? What will be the formula for that? It will be 1 by 4 pi epsilon naught will be common in all of them. It will be Q1 by R1. And for a scalar quantity, charge sign is very, very important. So minus of Q2 by R2 plus Q3 by R3. Are you able to get me or not? You got the idea? So this was about your potential, how potential is related, and how potential is related with work done. And then we talked about potential energy. Is that clear? ठीक है. तो थोड़ा सा how to define E and V for the charges. We should do like that, isn't it? Okay. So we got to know so many things about potential and potential energy. So now what we will do, uh, we'll do some question like just remember this electric field. So I'll just have a formula sheet of all these. See that if I have, I'll just have a quick recap. If I have Q1 and Q2 placed at some distance apart by some r distance, then they experience force on each other, and that force was K Q1 Q2 by R square, isn't it? Now, if I just keep one charge and then see, the point was very simple in physics that sir हमको तो we were aware of we were aware of dual charges. Everything was aware to us for dual charges. But Faraday was that scientist who started to understand what happens for the single cases. Because if they are applying the force on each other, then they have a field, they have a ability, isn't it? Are you able to get me? So that's why, so he defined first thing electric field intensity at this point P, which is given as 1 by 4 pi epsilon naught Q by R square. Are you able to get me or not? And if this charge is fixed, remember that this charge is fixed, and if another charge suddenly appears, then this another charge experiences some force, and that force is equal to charge which is moving into electric field at P for the fixed charge. Are you able to get me or not? So keep in mind in electrostats there are two kinds of charges. One is moving and one is fixed charge. And based upon that whole thing depends. Okay. Got it? Next thing. If I have this Q1 for single charge, then we have potential at point P also. Electric field is a vector quantity which will be radially outward over here. Potential is a scalar quantity, so no need to think. That is exactly equal to 1 by 4 pi epsilon naught, just Q by R. Are you able to get me or not? And then if I have once again system of charges, if I have force, then I have potential at that point if a charge is brought from infinity, which is K Q1 Q2 by R. So see that one formula is for interaction and another formula is for independent cases. Are you able to get me? Where one formula is for work done, that we know that work done is equal to force dot displacement, and that is equal to negative of change in potential energy. So that relates force, got it? And then we have potential which relates work, which is work done by charge moving, and that is equal to potential finally after charge moving if charge is brought from infinity, right or not? So two formulas for case of interaction, two formulas for single cases, and two formulas for case of what? Moving and being at stationary. Right or not? And based upon these six formulas, your whole physics depends of class 12. Okay. So this is what you have to keep in your mind always. That whenever you are solving, whenever you are thinking, you have six formulas to always counter upon. Which suits the more you have to apply. ठीक है? So two cases are there for moving. Work done is equal to force dot displacement is equal to negative of change in potential energy, and potential at any point is work done by charge moving or potential by charge moving. Right or not? ठीक है? चलो. So let us do one question. If I have charge minus Q, and evening when you will, are you free evening today also, or you will be having classes? Okay, you have dentist appointment. Okay. True. No problem. No problem. Okay, so look over here. This is point A and this is point B. Okay. There are two charges and this gap is of 4A This gap is of 4a. This gap is of 4a, and this gap is of 3a. Got it or not? Question is find E and V. Sorry, E and V at point A and B. Question number 2. If a charge minus Q and mass M is placed on point A, then find F net on it and its potential energy. Got it? Repeat same for point B. ठीक है? Third question. You have to do it as a homework. Got it or not? Find the work required to move the charge from point A to B. Got it or not? So these are your 3 questions which you will solve, and then I'll discuss it tomorrow. Okay? चलेगा? ठीक है?